Okay, so in the last video, we spoke about adding and subtracting rational functions. But first, we always went over how to do it with regular fractions first, because it's the same with fractions as it is with rational functions. So what happens when the denominator is not the same? You have to find a common denominator. So what is the common denominator the common number that both 2 and 3 go into? Well, they both go into 6, right? Now, they technically both go into 6 and 12 and any multiple of 6, right? So why don't we use 12, right? Why don't we use 24? Even though they both go into it, is because you want the smallest number that they both go into. This number right here is called, or like we call it the common denominator, but really what it is the least common multiple, or LCM, which is the smallest number that is both a multiple of 2 and a multiple of 3. So therefore, it is the common multiple that is the smallest, right? The least. So 6 is going to be our common denominator, or our LCM here. And so in order to get from 2 to 6, I have to multiply it by 3. So therefore, I multiply the top by 3. So I'm going to do 1 times 3, which is 3. And then in order to get from 3 to 6, I multiply it by 2. So I multiply the top by 2. And so therefore I get 4. And then I can do my regular math, which is 3 plus 4, which is 7 over 6. It's already simplified. So let's talk about how to find the least common multiple when it's not as easy. So just like 2 and 3, if 7 and 10 have no commonalities, you just multiply them together, right? These two have no common factors, right? This is just 7 and 1. This is just 5, 2, 10, and 1. The only common factor is 1. So therefore, the least common multiple is going to be them multiplied together. But when you look at something like this, where you have 5 and 10, 5 is a factor of 10. So therefore, the least common multiple is going to be 10, because 10 goes into 10 and 5 goes into 10. So what about something like this, where it's 12 and 16? This isn't as easy. So this is how you find the least common multiple of two numbers. It works for these two, but these two are just simpler, so we don't have to necessarily go through all that. So what I'm going to do is I'm going to list out what is 12, what are all of my prime factors of 12, right? If I break 12 down, it's going to be 6 and 2, and then 2 and 3, right? So 12 is the same thing as me saying 2 squared and 3 to the first times 3 to the first, right? 2 squared and 3 to the first, which is 4 times 3, which is 12. And then I have 16, which if I break it down is 4 and 4, which is 2 and 2 and 2 and 2. So therefore, it is 16 is equal to, and I'm going to use the same color for the same factor, 2, not squared, 2 to the 4th power. So in order to get the least common multiple between 12 and 16, what you're going to do is you're going to take whatever factors there are. 2 and 3 are the only factors that exist in 12 and 16, and you are going to take the highest degree that exists. So the highest degree of the 2 is a 4, and there's only one 3, so therefore it's 3 to the first. And so I multiply these together, and I get what? 2 to the 4th is 16, and I multiply it by 3. 16 times 3 is 48. So that is going to be your least common multiple. So it's 48. And that's how we got it. So that works with all of these types of problems, even when we're dealing with variables. So whenever you're dealing with variables, you just deal with the numbers separately than the variables. So if I have numbers, so I have to find the least common multiple between 6, 15, and 9. So I'm going to do the same concept. So 6 is the same thing as 2 and 3. 15 is the same thing as 3 and 5. And 9 is 3 and 3. So I'm actually just going to rewrite the 3 and 3 as 3 squared. So the only the only factors that exist are 2, 3, and 5, right? 2 here, 3 here, and 5 here. Now the question is, what is the highest degree of 2 that exists? Is 1. What is the highest degree of 3 that exists? Is 2. And what is the highest degree of 5 that exists? Is 1. It's kind of like the higher it is the winner, right? The biggest one is the winner. So these win, okay? And so therefore, my least common multiple between these three is going to be 2 times 9 times 5, which is 10 times 5, which is 90. So that's going to be my number portion of my answer. Write this down over here. So let's write this in red. So this is going to be 90. So I know that it's going to be 90 something. Now, the question is, for the variables, all you have to do is write down the variables. We only have x and y, and the same concept. Which number has the highest degree of x? It is this one, and it is 2. So therefore, this 2 wins. And then for y, which one has the highest degree of y? This 4 wins. So this is the least common multiple. What about something like this? Well, for this one, you would have to factor first. So I'm going to factor out the y squared, and then I get y squared plus 8y plus 15. And so I get y squared, y plus 5, and y plus 3, reverse FOIL. So that's one of them. And then for this one, I just have to do reverse FOIL. So it's what two numbers multiplied of negative 40 and then negative 3, negative 8, and positive 5. So now I have these two to deal with. Now again, these are factors. So it's the same concept. What are the factors that exist? Well, I know that y is one of the factors, y plus 5 is one of the factors, y plus 3 is one of the factors, and then y minus 8 is one of the factors. So I'm going to write y plus 5, y plus 3, and y plus 8, or y minus 8. And then you write the highest degree that exists between the two. So it's going to be y squared, right? So that y squared comes down. It is going to be just y plus 5 because both of these have a first degree. So therefore, first degree is what the least common multiple is going to have. And then both of these are first degree because they only exist once, so you don't even need to look at it, really. So there you are. There's your least common multiple. I mean, you would write it closer together, right? Y squared, y plus 5, y plus 3, and y minus 8. So therefore, this would be your common denominator. Okay, so we already did an example of this. Actually, yeah, we already did an example of this. We're going to move on. So if I have something like this, where I need to find the least common multiple between 2x cubed and 8xy squared. So the first thing is, what is the least common multiple between 2 and 8? Well, 2 is a factor of 8, so that's easy. It's just going to be an 8. Then I have x's and y's, so I'm going to write x and y. Now, what is the highest degree of x? Here it's a 3, here it's a 1. That's not 3 is higher than 1, so therefore it's going to be 3. And then y only exists once, and so we're going to take this 2, and it's going to be here. So that is going to be my common denominator. Okay, so my common denominator is going to be 8x cubed y squared plus 8x cubed y squared. So the question is, what would I have to, let me do this really quickly. Marker, white. Let's get rid of this. I need more space. Okay, what would I have to multiply 2x cubed by to get 8x cubed y squared? So you're going to take each part, right? So 2x cubed. What do I multiply by 2 to get 8 is going to be 4, right? 2 times 4. The x cubed already exists here, but I need to multiply it by y squared. So that means that I'm going to multiply both the top and the bottom by 4y squared. So up here is going to be 3y times 4y squared. And then the next question is, what do I multiply 8xy squared by to get 8x cubed y squared? Well, what's missing? The y squared is already there, the 8's already there, and I only have one x, so I need to get 2 more x's there. So I'm going to multiply it by x squared. So I end up having 5z times x squared. And then I just simplify from there. So for here, 8x cubed y squared plus 8x cubed y squared. And so this becomes 12y cubed. And this becomes 5x squared z. And then you just add the numerators. Now we're back to the problems from the last video. Becomes one fraction, 8x cubed y squared, and then 12y cubed x squared z. Oh no, plus. Ooh, I made a mistake. Plus 5x squared z. Don't know why I did that. There you go. All right, let's try another one. What about something like this? Now this is pretty easy because unlike this problem, for this problem, we had common factors between the denominators, and so therefore we had to find the LCM by doing all what we did. But for something like this, x and x plus 2 are singular linear factors. So the LCM between x and x plus 2 is just them multiplied together, just like if it was 7 and 10, like we did earlier. So my LCM is going to be x times x plus 2. And so therefore, this becomes really easy because if I want this to be x and x plus 2 minus, this is a minus, x times x plus 2, all I got to do is multiply the numerator by the opposite. So this is just times x plus 2, right? Because I'm multiplying both of these by x plus 2. And then the denominator here, the numerator here gets multiplied by just x. So it's 5x plus 3 times x. So it's both, everything is being multiplied. And then you simplify from there. So I'll write it over here. And so I get, I'm gonna actually write it all now as 1. So x plus 2, you always keep the denominator factored. So this becomes 2x plus 2 plus 4 minus, and then if I distribute that x, it becomes minus, I'm going to keep this in parentheses, 5x squared plus 3x because I need to distribute this negative. And so I get 2x plus 4 minus 5x squared minus 3x, right? I distributed that negative. And then I just combine like terms. So this becomes negative 5x squared, always go standard form. 2x minus 3x is negative x plus 4 over x x plus 2. All right, let's try another one. So if I have something like this, my common denominator, so I'm actually just going to set it up. We're not going to finish the problem. I think it's really important to set it up, and everything else gets really simple after that. So what is my least common multiple? Well, my least common multiple between 6 and 2 is going to be 6, because 2 is a factor of 6. Then what are my factors that exist? I have an x minus 3 in both, so that means x minus 3 is going to be in my common denominator. Only once, because it's only once here, it's only once here, so it only has to be once here. There's no places where you see x minus 3 squared, so you do not need to make it squared. And then we have a 2x minus 1. That's going to be my common denominator. So the question is, what am I going to multiply each of them by? Well, this already has the 6 and the x minus 3, so I just have to multiply this side by 2x minus 1. And then this side has the 2 factors already, but it has a 2 here, not a 6, so I need to multiply both of these by 3 to make that 2 a 6. And so therefore, my fraction ends up becoming, and if you want, after you do that, you can really just make it one fraction from here. I think it makes it easier. So I have 5 times 2x minus 1 minus 3 times x minus 1, and you can even just distribute that negative 3. And then you can do the math from there. And then this one, let's just talk about what the least common multiple is. But when you have something like this, now this one had no common factors, no simplifying, but sometimes you're going to have to simplify it first. So I'm going to actually factor this out, and you're going to get 5x times x plus 1. So when I have it where this becomes 5x times x plus 1 over all of this, right? X times x plus 3 squared, x plus 1, and x minus 2. I'm actually going to take this squared out. We're going to pretend that box isn't there. But yeah, there's no squared here. So what happens here? What can I cancel out? I could take this x plus 1 out, which makes my problem a whole lot simpler. So now I have 2 times x plus 3 squared plus 5x. Oh, and I can also take out, my bad, this x and this x, which again also makes it a lot easier. So now I have a 5 over x plus 3 and x minus 2. And so what's my LCM? Well, my least common multiple is going to be, well, there's an x on this side, which I need. There's a x plus 3, the biggest number that exists is squared, and then there's an x minus 2. And so in order to get this, what's missing here is just the x minus 2, and what's missing here is going to be an x and an x plus 3. So we have to multiply both. And so then we would bring it together, and we would get 2 times x minus 2 plus 5x times x plus 3 over my common denominator, which is going to be x plus 3 squared, and then x minus 2. You then distribute and combine like terms, and you will get your final answer.